This lesson deals with supplemental problem 3.5. You can find this problem in the ECE201 ebook in the Chapter 3 Supplemental Problems on page 5. Let's solve for the current I1 in supplemental problem 3.3, this time using superposition. If you recall in that problem, there were 4 voltage sources, 30 volts shown here, and there was a 15 volt source, a 3 volt source, and a 20 volt source. Setting those equal to 0, we then have the 3K in parallel with the 1K in parallel with the 4K. And then that's in series with the 2K. So I found the parallel combination of 4K, 1K, and 3K using my calculator and a technique we talked about in the supplemental problems in Chapter 2. I found that the result was 631.6 ohms. Now when you have resistors in parallel, the result is always smaller than the smallest resistor. In this case it was 1K, and the 631.6 seems reasonable. Now that's in series with 2K, and divide that into 30 volts and we get 11.4 milliamps. This is the current I1, but due to the first source, we'll use a prime with the value of I1. Okay, now let's set the 30 volt source equal to 0. That was this front one here. And then we had a 15 volt source set equal to 0. And I'm going to combine the 3 and the 20 volts here into just one source with our equivalence relationship. I basically have a voltage divider. And if I could find the voltage across this parallel combination, then I can solve for the current I1 due to the second source. So again, use my calculator, put a 2K, a 4K, and a 1K in parallel. Found that to be 571.4 ohms. And again, that seems reasonable since my smallest resistor is a 1K. Now with this polarity, I would need a voltage here of this polarity, but this would be minus 23 volts. So my voltage divider then would be the 571.4 divided by 571.4 plus 3K, and then multiplied by minus 23 volts. And that turned out to be minus 3.68. But the current I1 is flowing in this direction, so I need to know the voltage across the 2K resistor with that polarity. And that's going to be the negative of what I had. So the voltage across the 2K shown here would be a minus 3.68 divided by 2K, and that's 1.84 milliamps. Okay, I've set all the sources except the 15 volt equal to 0. And now what I've got is a 2K in parallel with a 4K, but that's actually in parallel with a 3K back around here. And again, the parallel combination will be smaller than the smallest resistor, in this case 2K. I found that was 923.1. Again, that seems reasonable. I can have a voltage divider to find the voltage across here because I have 3 parallel resistors, the 2K, the 4K, and it's actually 3K coming around the other side. So that's going to voltage divide with 1K, and the polarity in this direction would need a voltage in this direction. That would be a minus 15 volts. So minus 15 times the 923.1 over that plus 1K, give me the voltage V sub y. And that's a minus 7.2. And again, I need the voltage across the 2K resistor in this direction. Get the current I1, again, do the third source. So I'll take the negative of V sub y, it'll be a plus 7.2, divided by 2K, and that's 3.6 milliamps. Now by superposition, now we can add all the results. We have the results of the 30 volt source, the 23 volt source, and then the 15 volt source. I get 16.84 milliamps. It's exactly the same result I had in supplemental problem 3.3. This is supplemental problem 3.5.